Well, it's springtime. My allergies are acting up. I know it's springtime. And the book has an interesting optimization problem about planting gardens. So let's talk about this problem. Actually, it's the problem in the text. Oh, I didn't write the page number down. Let me just find it quickly. Does anybody have their book handy? You might be able to find it quicker. It's the problem, some of you probably done it already. Chapter 9, the problem with Mr. Green Thumb. Does that ring a bell? Maybe you haven't gotten to that problem yet. All right, so let's take a look at this problem. Okay, this is on page 241, and it's problem 2 on page 241. Okay. It's a word problem. So it's a type of problem, I like, and this is the type of problem I might very well ask on an exam. Mr. Green Thumb wishes to mark out a rectangular flower bed using a wall of his house as one side of the rectangle. So let me just draw you a little picture. From a bird's eye view, the house looks like this. From a bird's eye view, the house, this is a kind of a funny house. It has a flat roof, so we're not going to worry about that. So this is the house looked at from above, and this is the wall of the house he's thinking about using as one of the sides of the flower bed. Now, Mr. Green Thumb has some wire netting in his garage, and he has 64 feet of this wire netting available. So the length of fencing he has is 64 feet. Okay. And he wants to take this wire netting and trace out a rectangular flower bed. So his flower bed's going to look something like this. This would be one side. This would be a length. And then here would be another side. Okay. So let's label this the width, W. And let's label this as the length of the flower bed. Notice the house provides one side, so you don't have to worry about that. The side is already provided to by the side of the house. But you do have two widths, just one length. So it has 64 feet of wire netting, and Mr. Green Thumb consults you, because he knows you've had this course, and he asks you, what are the dimensions he should choose for this flower bed in order to get the largest planting area possible. Okay. So this is an optimization problem, and what he wants to do is what? In words, what is the objective in words? David? Well, what is the objective? Don't give us the answer yet.
Maximize the amount of space he has for his garden.
Right, okay. And actually, the amount of space he has would be this space contained within these four sides here. And what would we call that space? What's the name for that? Area. It's just really the area of the rectangle. So the objective is to maximize the area. Okay. Let A stand for area. And you learned in high school that the formula for the area of a rectangle is what? What is the formula that gives you the area of a rectangle? Width times the length. So it's W times L. But again, we're running into a problem we ran into before. Notice that area is a function of two variables. What we would like is to get area expressed as a function of a single variable if we could. That would allow us to use the tools we've learned. How could we do that? Is that going to be possible? Johnny? Yes. Exactly. Your length of fencing, we got to use that information. The length of fencing is just going to be equal to 2W plus L. And now we can use this equation right here to substitute for L, let's say, in terms of W. And rewriting this equation, we could write L is equal to 64 minus 2W. See, this is similar to what we did when we eliminated P earlier and got revenue expressed as a function of Q alone. Now we're getting area expressed as a function of W alone. Now just substitute in this expression here for L, and we get area equals W times L, which is this, 64 minus 2W. Or area is a function of W. A of W is just 64W minus a 2W squared. Now this is our objective function. That's the thing we're trying to maximize. This is the difficult part of the problem. Because once you've got the objective function, then what do you do, David? Yeah, take the derivative. And what is A prime of W here? Right, 64 minus 4W. And what do we do with that, David? We got the first derivative. Now what do we do with it? Well, back up a second. There's one more thing we have to do with the first derivative first. What do we do to that first derivative? Yes, set it equal to 0. And by solving this equation, what we will get is the critical value of W. Okay, and if we solve this equation for W, we get 64 equals 4W. Or we get W equals 64 over 4, which is 16, isn't it? Is that right? Wait, is that right? Yeah, okay, thank you. Yes, okay. That is our critical value of W. That makes the first derivative 0. That is our critical value of W. Now, David, after we've done that, what's the third step? Yeah, take the second derivative. And A double prime of W? The second derivative is equal to what? Negative 4. Notice that second derivative is always negative. So that means at W equals 16, we have what, Brittany? At W equals 16, at our critical value of W, you have a maximum because the second derivative is negative. So that guarantees that A of 16 is a relative max. Okay. And in fact, A of 16 is what? Well, if we go back to this equation right here, A of 16 is 64 times 16 minus 2 times 16 squared. Now, I don't know if I actually calculated that in my notes, but do that calculation. and you'll get the maximum area. Actually, we could quickly figure it out. If this is 16, what is this? What is L equal to? 64 minus 32 is 32. Our L value is 32. So it's 16 times 32. What is that equal to? 16 times 32? Anybody help me out? What is it? 512. Thank you. So that would be our maximum, 512 square yards. A of 16 is equal to 512 square yards. And those dimensions will give Mr. Green Thumb the maximum area. Now, it is interesting, David, you said something about a square. In this case, it's not a square, is it? Exactly. That's why it's not a square, because you can take advantage of your existing house to provide one side for you. If we redid this problem such that it was going to be a freestanding garden, not adjoining your house, then it would turn out that the rectangle that maximizes the area would be a square, but not in this case here. Yeah. Okay. I'll let you redo this problem. Assuming you're going to build, you have 64 feet, and you're going to make it a freestanding garden. So all four sides then have to be enclosed by the wire netting. And I'll just tell you the answer. David is right. In that case, it is a square. But I'll let you work that out. That would be a good problem to put on the test. Yes? David, did you want to say something else?
I don't know. I'm just curious why was that 32 on length double with the a square would be.
Yeah. I don't know that I could give you an intuitive answer, but it does make intuitive sense for you to make the dimensions such that the length is much greater than the width, because that way you can sort of take advantage of this free side, basically. Okay. All right. Okay. That's all for today. Have a nice holiday, and I will see you back here on Monday.